Hello, this is video number 26 on my single variable calculus 2. In this video, we're going to talk about Taylor polynomials. What are Taylor polynomials? Taylor polynomials are the partial sums of Taylor series. So the nth Taylor polynomial is the sum from 0 to n of fk of x naught divided by k factorial multiplied by x minus x naught to the power of k. And this x naught is the center for the Taylor series. Okay, so let's do a few examples on this. So the first two examples are find the third and fourth Taylor polynomials of each of the following functions centered at the given points. So in order to find the Taylor polynomials, we have two strategies that we can use. Either find the Taylor series and then pick the portion that is of degree third or fourth, or just find the Taylor polynomials directly using the formula. Well, we don't really have the Taylor series for tangent of x, so we'll have to just use the process of finding the derivatives one by one. So if f of x is tangent of x, then we'll have to plug in pi over 4, so we get 1. Let's take the derivative of that. Well, f prime of x is secant squared of x. Then we are going to plug in pi over 4. Secant of pi over 4 is root 2, and then we square that, we get 2. F double prime of x is 2 secant of x, so that is the power rule, but then we have to multiply by the derivative of secant, which is secant tangent. Let's simplify that. We get 2 secant squared of x, tangent of x. Now let's plug in pi over 4. We get 2 times root 2 squared, that is 4 times 1. So the answer to this one is 4. Things get a little bit more complicated when we get to the third derivative. So we'll have to use product rule. So we get 4 secant of x, that's the power rule, but I'll have to use the chain rule. So secant times tangent again. So that's the product rule. So I'm taking the derivative of this one, which is going to be that. So 4 secant times derivative of secant times tangent plus 2 secant squared of x, and then times the derivative of tangent, which is secant squared of x. Then I'll have to plug in the value of pi over 4. I will get, well, here I would get 2 if I substitute pi over 4, because secant of pi over 4 is root 2. Square that, we get 2. This one is 1. This one is 1. So we get 4 times 2 times 1 times 1. So we get 8 plus this one is 2. This one is also 2 plus another 8. So this becomes 16. So that is the third derivative. Let's simplify that so we can take the fourth derivative as well. So this is 4 secant squared of x times tangent squared of x plus 2 secant to the fourth of x. Now let's take the derivative of this. So f4 of x equals, so we'll have to use the product rule. So we get 8 secant of x. That's the power rule. Then we have to multiply that by secant times tangent, and then times tan squared. So this part is the derivative of 4 secant squared. And then I'll have to find the derivative of tan squared. So this would be 4 secant squared of x times 2 tangent of x times secant squared of x. This part is the derivative of tan squared, and then plus 8 secant cubed times derivative of secant. So I'm using power rule and then the chain rule. Now let's plug in pi over 4. So we get f fourth of pi over 4, the fourth derivative of f at pi over 4. So this portion is 2. We have 1 here. We have 1 here as well. So we get 8 times 2, that's 16, plus this is 2. That is also 2. There's another 2 here. So 4 times 2 times 2, that's 16. Times 2, that is 32, plus this is 4, root 2 to the fourth, that's 4, multiplied by 1, that's 32. So that is 16 plus 64, and that is 80. So these are the numbers that we need. Now we need to find the third Taylor polynomial. So the third Taylor polynomial is, well, I have to find f of pi over 4, which is 1, plus the next coefficient is 2 divided by 1 factorial. The first one is divided by 0 factorial times x minus pi over 4 to the first. The next one is 4. The next derivative is 4. We found it here. So that's 4. That's the second derivative divided by 2 factorial, x minus pi over 4 squared. And the next derivative is 16. This is the next derivative that we found, 16 divided by 3 factorial, x minus pi over 4 cubed. So this would be 1 plus 2 x minus pi over 4 plus 4 over 2, that's 2 x minus pi over 4 squared, plus 16 over 6 is 8 over 3. So 3 factorial is 6. So that's why we get 8 over 3 times x minus pi over 4 cubed. So this is going to be the third Taylor polynomial of tangent at pi over 4. The fourth one is the same, except we have to add one more term. So 1 plus 2 times x minus pi over 4 plus 2 times x minus pi over 4 squared plus 8/3 x minus pi over 4 cubed, plus we'll have to multiply by f4 divided by 4 factorial. Fourth derivative of that is 80 divided by 4 factorial times x minus pi over 4 to the power of 4. So that's the fourth Taylor polynomial of tangent at pi over 4. The second part of this problem is sine centered at 0. Well, if I want to find the Taylor polynomial of that, well, I can use the Taylor series that we found. We found the Taylor series of sine as x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial plus minus etc. So the third Taylor polynomial would be centered at 0, because they said centered at 0, so that's why I wrote down the Taylor polynomial centered at 0. If it were at a different point, we didn't really have that. We haven't really calculated the Taylor series at other points. So for the third one, I'll have to go up to degree 3. So it would be x minus x cubed over 6. So this would be the answer to the problem. Now the fourth one, I'll have to go up to degree 4, but there is no degree 4. So it's actually the same as the previous one. So that's the same as the third Taylor polynomial. Let's look at one more example and then we will summarize. We want to find the coefficient of x minus 2 to the power of 4 in the Taylor series for 1 over 1 plus x. So what we need is we need a4, which is the coefficient of x minus 2 to the power of 4. There are two solutions to this one. Solution number 1 is using the formula. The formula was fourth derivative at 2 divided by 4 factorial if the function is 1 over 1 plus x. So that's the first method. This is 1 plus x to the power of negative 1. So we can take the derivative. The derivative is negative 1 plus x to the power of negative 2. The second derivative is 2 times 1 plus x to the power of negative 3. The third derivative is negative 6, 1 plus x to the power of negative 4. And the fourth derivative is what I need. That is minus or plus 24, 1 plus x to the power of negative 5. Now we can plug in 2 here. We get the fourth derivative at 2 is equal to 24 divided by 1 plus 2 to the power of 5. So this is 24 over 3 to the 5th. And we can simplify this slightly. That is 8 over 3 to the 4. So a4 is going to be f4 of 2 divided by 4 factorial by the formula that we had up there. So this would be 8 over 3 to the 4th divided by 4 factorial. 4 factorial is 1 times 2 times 3 times 4. That is 24. So this would be 8 over 3 to the 4th times 24. We can simplify this. This is 1. This is 3. That is 3 to the 5th. 3 to the 4th is 81 times 3. So that would be 1 over 243. So the answer is 1 over 243. Here is the second method. The second method is writing down the Taylor series for 1 over 1 plus x, but it has to be centered at 2. If you want to center it at 2, what we do is we take u equals x minus 2 and we plug it in there. We get 1 over x becomes u plus 2, so it's 1 over 1 plus u plus 2. And then we use the geometric sum. So 1 over 3 plus u, which is 1/3 times 1 over 1 plus u over 3, which can be written as 1 over 1 minus negative u over 3. Now for this, we can use the Taylor series for 1 over 1 minus x. So this is the sum negative u over 3 to the power of n, and n goes from 0 to infinity. So this would be 1/3 the sum negative 1 to the n over 3 to the n, and then times u to the n. U was x minus 2 to the n, and n ranges from 0 to infinity. So now the question was find a4. Well, if I put this 1/3 inside, I would get the sum 1/3 negative 1 to the n over 3 to the n, x minus 2 to the n. N equals 0 to infinity. What is a4? a4 is this one when n is 4. So this means a4 is 1/3 negative 1 to the power of 4 divided by 3 to the 4, which is 1 over 3 to the 5th, and that's exactly 1 over 243 that we got up there. So to summarize, what we did in this video was we talked about the nth Taylor polynomial for a function, and the formula is fk of x0 divided by k factorial multiplied by x minus x naught to the power of k, and k ranges from 0 to n. And that brings me to the end of this video. I will see you in the next video.